welcome. This video is for CIE AS level 9709 Mathematics, Probability and Statistics, paper 6, and it is practice paper 9. So let's try to solve it out. This is practice paper 9. Till now we have done 8 papers. This is practice paper 9. Coming to question number 1. The 40 members committee or club includes Ranuf and Saeed. All 40 members will travel to the concert. 35 members will travel in coach and 5 members in a car. Rauf will be in the coach and Saeed will be in the car. So this is a coach and this is car. Rauf will be in the coach and Saeed will be in the car. In how many ways the members? So 40 members are done. So they are there 40 members. So two members has already been done. So 38 are left over. Now, in how many ways can the members who travel in the coach can be chosen? So, how many people are there in the coach? 35 are there. 35, but already Rauf is included, therefore it will be 34. So now, what is that? Out of 38, I need to select it out 34. So it is going to be 38C 34, which is going to be 73,815. Question number 2. An ordinary fair die is thrown repeatedly until 1 or 6 is obtained. So probability of 1, 6 will be 2 upon 6, which is 1 upon 3, which is success. So failure is going to be 2 upon 3. Find the probability that it takes at least 3 throws, but no more than 5 throws to obtain 1 or 6. So probability of 3 throws or 4 throws or 5 throws. So 3 throws to get this one. So first throw, second throw is fail, third throw is success. Over here, first throw, second throw, third throw are failure, fourth throw is success. First throw, second throw, third throw, fourth throw, and fifth throw is success. So this is going to be 2 upon 3 whole square times 1 upon 3, 2 upon 3 whole cube times 1 upon 3, 2 upon 3 whole power 4 times 1 upon 3, which is going to be 4 upon 27 plus 8 upon 81 plus 16 upon 243, which is going to be 2432 upon 7776. Simplify that, 76 upon 243, which is 0.313. On another occasion, this die is thrown 3 times. The random variable x is the number of times 1 or 6 is obtained. So if at all we are throwing 3 times, so how many times 1 or 6 can be obtained? Either 0 times, 1 times, 2 times, or 3 times. So that will be the probability, or number of times: 0, 1, 2, and 3. This is x. Probability of capital X equals to small x. 0 times. So probability of 0 times means 2 upon 3 whole cube, which is 8 upon 27. Then 1 time will be 1 upon 3 times 2 upon 3 whole square. Again times 3, because we can arrange it out in 3 ways, any one of the ways. So this will become 12 upon 27. Then probability of 2 times. 2 times is going to be 2 upon 3 times 1 upon 3 whole square times 3. This is going to be 6 upon 27. And finally 3 times. 3 times is going to be 1 upon 3 whole cube, which is 1 upon 27. Find the expected value. So expected value will be 0 times 8 upon 27 plus 1 times 12 upon 27 plus 2 times 6 upon 27 plus 3 times 1 upon 27, which is going to be 1. That's going to be the answer. Now coming to question number 3. So the question number 3, the time spent by shoppers in a large shopping center has a normal distribution with the mean 96 and standard deviation 18. Mean is 96 and standard deviation is going to be 18. Find the probability that the shopper chosen will lie between 85 and 100. 85 and 100. So it's going to be probability of x less than 100 minus probability of x less than 85. So probability of z less than 100 minus 96 upon 18 minus probability of z less than 85 minus 96 upon 18. So probability of z less than 0.2222 minus probability of z less than minus 0.611. So probability of z less than 0.2222 minus 1 minus probability of z less than 0.6111. So which is going to be nothing but how much? 0.5879 plus 0.7294 minus 1, which becomes 0.317. 88% of the shoppers spend more than t minutes. So probability of x greater than t equals to 0.88. So probability of x less than t equals to 0.12. Probability of z less than t minus 96 upon 18 equals to 0.12. This 0.12 is not there in the table. If at all it is not there in the table, subtract from 1, so it becomes 0.88 and swap this. Probability of z less than 96 minus t upon 18. So it becomes 96 minus t upon 18 equals to 1.175. So 96 minus t equals to 1.175 times 18. So t equals to 96 minus 1.175 times 18, which is going to be 74.85. Three significant figures, 74.9. Question number 4. Coming to question number 4. A company sells small and large bags of rice. The masses of small bags of rice is normally distributed with mean 1.2 and standard deviation 0.16. A random sample of 500, how many would you expect have more than 1.26? So probability of x greater than 1.26, which is probability of z greater than 1.26 minus 1.20 divided by 0.16. So which is probability of z greater than 0.375, which is 1 minus probability of z less than 0.375, 1 minus 0.6462, which is 0.354. But this is for how many? 500. So therefore 500 times 0. This is 3538. Simplify that, you should be getting 176. The masses of large bags of rice are normally distributed with a mean 2.5 kgs and standard deviation sigma. 20% of these bags of rice have a mass less than 240. Probability of x less than 2.40 equals to 20 upon 100. So probability of z less than 2.40 minus 2.50 by sigma equals to 0.2. Again, this is not in the table. When it is not in the tables, subtract. So it becomes 0.8 and this becomes swapped. So z less than 2.50 minus 2.40 by sigma. So this is going to be 2.450 minus 2.40 by sigma equals to 0.842. So sigma equals to 0.1 divided by 0.842, which is going to be 0.119. The random sample of 80 large caps, 80 large bags. So n equals to 80. Find the probability that fewer than 22 bags of these large bags of the rice have a mass less than probability of x less than 2.40. is nothing but what? 20%. This 20% becomes P. So P equals to 0.2. Q equals to 0.8. So mean equals to NP, which is 80 times 0.2, which is 16. And variance equals to standard deviation equals to square root of NPQ, which is square root of 80 times 0.2 times 0.8, which is 12.8 under square root. Now what is he asking? Probability of x less than 22, which is probability of z less than 21.5, because approximation 21.5 minus 16 divided by square root of 12.8. Probability of z less than 1.537, which is nothing but what? 0.938. Now coming to question number 5. In Greenton, 70% of the adults own a car. A random sample of 8 adults are chosen. Find the probability the number of adults in this chosen is less than 6. So less than 6. Less than 6 is going to be what is this? 0, 1, 2, 3 and so on till 5. So what am I going to do? Rather than that one, I can do 1 minus probability of x equals to 6 minus probability of x equals to 7 minus probability of x equals to 8. So 1 minus 8C6, success is 6 times and remaining 2 times failure. 8C7, success is 7 times, failure is 1 time. 8C8, success is 8 times, failure is 0 times. So this is going to be 1 minus 0.55177, which is 0.448. Question number part B. A random sample of 120 adults. So n equals to 120. Then more than 75 own a car. So probability of success is 0.7. Probability of failure will be 0.3. So mean equals to NP, which is 120 times 0.7, which is 84. Then standard deviation is square root of NPQ, which is square root of 120 times 0.7 times 0.3, which is 25.2. More than 75 them own a car. So probability of x greater than 75 equals to probability of z greater than 75.5 minus 84 by square root of 25.2. Probability of z greater than minus 1.693. 1 minus probability of z less than minus 1.693. So 1 minus probability of z less than 1.693. So which is probability of z less than 1.693, which is going to be 0.955. Now coming to question number 6. In a cycling event, the times taken to complete a course are modeled by again a normal distribution with a mean and a standard deviation. Find the probabilities less than 74 minutes. Probability of x less than 74, which is probability of z less than 74 minus 62.3 divided by 8.4, which is probability of z less than 1.393, which is going to be 0.918. Find the probability that 4 randomly chosen cyclists all have the times between 50 to 74. So probability of x lies between 50 to 74, which is probability of x less than 74 minus probability of x less than 50. So probability of z less than 74 minus 62.3 divided by 8.4 minus probability of z less than 50 minus 62.3 divided by 8.4. Probability of z less than 1.393 minus probability of z less than minus 1.464. Probability of z less than 1.393 minus 1 minus probability of z less than 1.464. So this is going to be 0.9285 minus 1 plus 0.9182, which is going to be 0.847. But this is for 1. 4 random all have the same time. So first one is 0.847 and second one is 0.847 and third one is 0.847 and the fourth one is also 0.847. Answer is 0.514. In a different cycling event, the times are modeled by normal distribution. 23% of the cyclists have less than 26 in 36 minutes. Probability of x less than 36 equals to 23%. So probability of z less than 36 minus mu by sigma equals to 0.23. This value is not there in the table. So therefore, what am I going to do? Subtract from 1, 0.61 and swap this. Probability of z less than mu minus 36 by sigma. So mu minus 36 by sigma equals to 0.739. Then this have greater than, what is this, 54. So less than 54 will be, what is this, greater than 54. So less than 54 will be the remaining 90% of the cyclists. So probability of z less than 54 minus mu by sigma should be equals to 0.9. So 54 minus mu upon sigma equals to 1.282. So 1.282, because he's telling that greater than 54 is 10%. So less than 54 will be the remaining 90%. So from here I get two equations. First equation is mu minus 36 equals to 0.739 sigma. 54 minus mu equals to 1.282 sigma. Then what am I going to do? I am going to add these two equations. So which is going to give me 18 equal to 0.739 sigma plus 1.282 sigma. Then when I do by the calculator, sigma equals to 18 divided by, so I take the calculator and take 18 divided by, so first of all I'll add 0.739 plus 1.282, which becomes 2.021. So 18 divided by 2.021 gives me 8.91. 8.91 is the answer. Now plug in this one. So mu minus 36 equals to 0.739 times 8.91. This gives me mu value as 42.6. Coming to the last question, question number 7. This question number 7 is from the permutations and combinations. Now over here, 8 children of different ages stand in a random order in a line. Find the number of different ways this can be done if none of the 3 young children stand together. So there are 8 children. So none of them should be standing together. So minus 3 children. So 5 children. So first of all, I'll arrange that 5 children. Child 1, child 2, child 3, child 4, child 5 in order. So what's going to be the factor? 5 factorial. Now how many alternate places are created? We can see that 1, 2, 3, 4, 5, 6 alternate places are created. But how many, what is this, young children are there? 3 young. So 6p3. Those 6 children, those 3 children, 3 youngest children have how many places? 6 places. This can be arranged in how many ways? 6p3 times this 5 factorial. So 6p3 times 5 factorial, which is 14,400. David chooses 5 chocolates, 6 dark chocolates from 6 dark chocolates, 6 dark chocolates, then 4 different white chocolates, 4 different white chocolates, and 1 milk chocolate. From this one, he has to choose it out. Totally how many chocolates? He has to choose 5. At least one of each type. Find the number of ways he can do that. So let me start with 1, 2, 2. Then 1, 1, 3. Then 1, 3, 1. These are going to be the ways. So it becomes 6c2 times 4c2 times 1 plus 6c3 times 4c1 times 1 plus 6 times 4c3 times 1, which is going to be 90 plus 80 plus 24, which is going to be the answer 194. Finally, coming to part C. A password for Chelsea's computer consists of 4 characters in a particular order. The characters are chosen from random from the following 26 alphabets, 9 digits, and symbols. The password must include at least one capital letter, one digit, one capital letter, one digit, and one symbol. And no character should be required. Then totally should be 4. So 1, 1, 2, or 1, 2, 1, or 1, 1, 2. This is going to be the way. So it's going to be 26c2 times 9c1 times 5c1 times 4 factorial. Then 26c1 times 9c2 times 5c1 times 4 factorial. Then 26c1 times 9c1 times 5c2 times 4 factorial. So this is going to be 351,000, 112,320, 56,160. Add them all. The final answer is going to be 519,480. That's going to be the answer. That completes the paper. See you in the next paper. Bye.